Chapter 4 Simple Pendulum. Experiment number 4. Aim of the experiment: A. To verify the law of simple pendulum. B. To determine the value of acceleration due to gravity at a place using simple pendulum. Apertures required: first, metallic bulbs of different size and materials. Second, inextensible thread. Third, retort stand. Fourth, split cork. Fifth, stop clock. Sixth, meter scale. Seventh, vernier calipers. Formula: first, time period T is equal to constant for bulbs of different size and materials at a constant length of simple pendulum. Second, time period T is equal to constant for different amplitude of oscillation at a constant length of pendulum. Simple pendulum. Third, value of L upon T square is equal to constant where L is the length of simple pendulum and T is the time period. Fourth, acceleration due to gravity G is equal to 4 pi square L upon T square. Description: a heavy metal sphere of small diameter suspended from a rigid support by means of thin, inelastic and weightless string is called simple pendulum. The simple pendulum consists of small metallic sphere called a suspended by a thin string. The other end of the string is passed through a split core fixed tightly in the clamp of a retort stand as shown in figure 1. Theory. Definitions: length of simple pendulum: the distance between the center of the bulbs to the point of suspension O is called length of the simple pendulum. Oscillation: the to and fro motion of a body about a fixed point or mean position is known as oscillation's time period. The time taken by simple pendulum to complete one oscillating is known as time period. Amplitude: the maximum displacement of an oscillating body from its mean position is known as amplitude. Frequency: the number of oscillations made by simple pendulum in 1 second is known as frequency. Acceleration due to gravity G: the acceleration produced in a freely falling body by the gravitational force is known as acceleration due to gravity G. Law of simple pendulum. First law: time period of oscillation of simple pendulum is independent of the size, shape and mass of the bulb if the length of simple pendulum kept constant. Second law: the time period of oscillations of simple pendulum is independent of its amplitude if the length of the simple pendulum kept constant for small amplitudes only. Third law: the time period of oscillations of simple pendulum is directly proportional to square root of its length, T proportional to root under L or T square proportional to L or L upon T square is equal to constant, where T is time period and L is length of simple pendulum. Procedures for verifications of law of simple pendulum. Verifications of first law of simple pendulum. First, using meter scale put the length of simple pendulum constant say 100 cm. Second, produce oscillations in simple pendulum by pulling it aside for a small angle and release it. Third, measure the time taken for 20 oscillations using stop clock and is noted in tabular form 1. It is the reading for trial 1. For repeat the same procedures as mentioned in 2 and 3, again measure the time taken for 20 oscillations and is noted in tabular forms. It is the reading for trial 2. Fifth, by changing different bulbs, experiment is repeated as mentioned in 2, 3 and 4 steps and noted in the table 1. 6. The value of time periods for each bulb is calculated. If the time period of simple pendulum is constant for all the bulbs, the first law of simple pendulum is verified. Verification on second law of simple pendulum. First, using meter scale, put the length of simple pendulum constant, say 100 centimeters. Second, produce oscillations in simple pendulum, pulling it aside for 2 centimeter from mean position and release it. Amplitude is equal to 2 centimeter. Third, measure the time taken for 20 oscillations using stop clock and is noted in tabular form 2. It is the reading for trial 1. Fourth, repeat the same procedures as mentioned in 2 and 3 again. Measure the time taken for 20 oscillations and is noted in tabular form. It is the reading for trial 2. Fifth, by changing the amplitudes as 4 cm and 6 cm, the experiment is repeated and readings are noted in tabular form. Sixth, the value of time period for each amplitude is calculated. If the time period for all the three amplitudes remains same, then second law of simple pendulum is verified. Table 1, verification of first law of simple pendulum, different bobs. Table 2, verification of second law of simple pendulum, different amplitude. Verification of third law of simple pendulum. First, the diameter d of the bob is measured 3 times using vernier calipers using table 3 and its average radius r is equal to d upon 2 is determined. Second, to simple pendulum is arranged by suspending bob to restore stand by means of a thin thread. The distance say from the point of suspension O to the bottom of the bob is measured using meter scale. Fourth, the length of simple pendulum L is equal to A minus R is calculated. Fifth, the length of the pendulum is adjusted to a convenient value, say 50 centimeter. Sixth, the bob is drawn to a side from mean position giving a small amplitude and released, then it begins oscillations in the vertical plane. Seventh, after few swings, a stop clock is started at the bob passes a fixed mark in one direction and is counted as 0. When the bob passes the fixed mark in the same direction, it is counted as 1. 8th, at the end of 20 oscillation, the stop clock is noted at the time for 20 oscillation is noted. This is for trial 1. 9th, the experiment is repeated and again time for 20 oscillation is noted. This is for trial 2. 10th, mean of trial 1 and trial 2 is calculated T from table 4. 11th, the mean time T is divided by 20 to get time period T. 12th, the value of L upon T square is calculated. 13th, the experiment is repeated for different lengths, say 60 cm and 70 cm, and in each case the value of L upon T square is calculated. If the value of L upon T square in each case remains constant, then third law of simple pendulum is verified. Observation for vernier calipers. Table 3, finding diameter of bob using vernier caliper. Table 4, verification of third law of simple pendulum, different length. Result, precautions, graphs. L T square graph. A graph is drawn between L on the x-axis and T square on the y-axis. The graph is a straight line passing through the origin. The value of L upon T square can be determined and hence G value at a place can be estimated. This value should be equal to the experimental value obtained. LT graph. A graph is drawn between the values of L on the x-axis and the value of t on the y-axis. Graph in a parabola as shown in figure. Questions. First, define the terms length of pendulum. Second, what is meant by acceleration due to gravity? Third, write the formula for time period of simple pendulum. Fourth, state the law of simple pendulum. Fifth, what is meant by second pendulum? Viva questions. First, what is simple pendulum? Answer. A point heavy mass suspended from a massless thread is called simple pendulum. Second, can we construct ideal simple pendulum? Answer. No, because point heavy mass and massless thread cannot be obtained in practice. Third, what is length of pendulum? The distance from point of suspension to the center of gravity of the bob is called length of pendulum. Fourth, what is second pendulum? The pendulum having time period of 2 seconds is called second pendulum. Fifth, does the second pendulum have more length at equator or at the pole? Answer. At the pole, second pendulum has more length. Sixth, what is law of isochronism? Answer. The time period is independent of amplitude provided the amplitude is small and length is constant. Seventh, what is law of gravity? For a given length of pendulum, the period is inversely proportional to square root of acceleration due to gravity at a place t proportional to 1 upon root under g. What is law of length? At a given place, the time period of pendulum is directly proportional to square root of its length t proportional to root under L. Ninth, what is the shape of LT graph of simple pendulum? Answer. Parabola or curve passing through origin. 10th, how is LT square graph of simple pendulum? Straight line passing through origin. 11th, how do you double the period of pendulum at a place? By increasing the length 4 times. 12th, what happens to period of pendulum if its length is doubled? Answer. The period becomes root under 2 times the previous values. 13th, what happened to period of pendulum if it is taken in a lift moving up with uniform velocity? Answer. Time period does not change. 14th, what happens to period of pendulum if it is taken in a lift moving up with acceleration? Answer. Time period decreases. 15th, what happens on time period if a pendulum is taken in a lift moving down with uniform acceleration? Answer. Time period increases. 16th, what types of energy is possessed by the bob of pendulum at any position other than extreme and mean position? Answer. Both kinetic energy and potential energy. 7th, what types of energy is possessed by the bob of pendulum and extreme position? P. E only. A pendulum has one hollow sphere as bob. What happens to time period if the sphere is completely filled with water and half filled with water? Answer. No change of period when the sphere is completely filled, but the period increases when the sphere is half filled. 19. Why does a simple pendulum stops finally? Due to friction between atmosphere and bob. 20. What is the velocity of bob at extreme position? 0. 21. What is the velocity of bob at mean position? Maximum. An oscillating pendulum is stopped, then will it continue oscillations? No. When An oscillating pendulum is stopped, its apparent weight is zero. It is a gravity-less state, so it does not oscillate. 23. Pendulum clocks are not used in satellites. Why? A satellite in the orbit is in weightless state, so pendulum does not oscillate, so pendulum clocks are not used. 24th. When a pendulum is taken into space where there is no gravity, then what is the time period of that pendulum? Answer: time period is infinity because pendulum does not oscillate in gravity-less condition. 25th. The interaction of LT square graph and LT graph corresponds to what time period? Answer: 1 second. If the two graphs intersect, then for given length LT and T square are same such that T is equal to T square. This is possible only when time T is equal to 1 second. 26th. If an oscillating pendulum is carried in a lift moving upwards with acceleration a, then what will be its time period? Time period in left t is equal to 2 pi root under 1 upon g plus a. 27th. If an oscillating pendulum is carried in a lift moving downwards with acceleration a, then what will be its time period? Answer: time period t is equal to 2 pi root under 1 upon g minus a. 28. Can we conduct pendulum experiment at the center of Earth? Answer: no. At center of Earth g is equal to 0, so pendulum does not oscillate. 29th. If amplitude of vibration of simple pendulum is high, what happens? Answer: the g values calculated may be erratic. The time period of simple pendulum t is equal to 2 pi root under L upon g. This equation is derived assuming that angular displacement of pendulum is less. If amplitude is high, the theoretical and actual time period may differ. 30th. What is compensated pendulum? Answer: it is a pendulum which maintains to constant length at all temperature. 31st. What is approximate length of second pendulum on Earth? Answer: 100 centimeter. It changes with g value. 32th. How can you find length of second pendulum from LT square graph? Answer: the intersection of line parallel to x-axis drawn from the point t square is equal to 4 with LT square graph gives length of second pendulum on x-axis. 33. A simple pendulum is made with a hollow cylinder filled with a liquid. If the liquid leaks through a hole at the bottom, what change is noticed in time period? The time period gradually increases. Time it will become half empty, then time period will decreases gradually. When it is totally empty, there is no change in time period. This is due to shifting of position of center of gravity when the liquid is leaking. 34th. What is acceleration due to gravity? It is the acceleration produced in freely falling bodies. What is gravity? Gravity is the force with which a body is attracted towards the center of the earth. 36th. What is the difference between gravity and gravitations? Answer: gravitation is a general term used to represent the force of attraction which consists between any two bodies in the universe. Gravity is particular case of gravitations, terms used to represent the force with which Earth attracts any other body or near its surface. 37th. How does G differ from G? capital G differ from small g? Answer. Capital G is a universal gravitational constant and small g represent acceleration due to gravity which varies from place to place. 38th. What is the weight of the body at the center of the earth? Answer. As the value of g at the center of the earth is 0, the weight is 0. 39th. What is an ideal simple pendulum? Answer. An ideal simple pendulum consists of a heavy particle suspended by means of a weightless extensible string. 40th. What types of motion does a simple pendulum execute? Answer. It executes simple harmonic motions. 41st. Definition of simple harmonic motion. Answer. It is a special case of motion in which the acceleration is directly proportional to the displacement of the vibrating particles and the acceleration is always directed towards the mean position. 42. How is time period of pendulum related to its length? Answer. By third law of simple pendulum, time period t is proportional to the square root of the length, t proportional to root under L. 43. Why is spherical bob referred to bodies of other shape like cylindrical or conical? Answer. The air resistance is minimum for spherical shaped bodies. 44th. What is meant by time period? It is the time to complete an oscillation. 45. What is one full oscillation? The complete to and fro motion of the bob. 46. What is amplitude? Maximum displacement of the bob from its mean position in amplitude.